So, you've got a handle on core Java, and you're probably standing at a crossroads, right? The path forward? Well, that leads to becoming a full-stack developer who can build some seriously powerful, real-world applications. Today, we're going to map out that exact journey. Let's dive in.
Yeah, you've put in the work. You get objects, classes, inheritance, all that good stuff. But you're probably asking yourself, how do I go from just writing code to building something real? Something people can actually click on and use. Well, that's exactly the leap we're about to take right now.
Okay, so first things first, let's get a lay of the land. We're moving way beyond those simple text-based console apps. Our first stop is going to be building graphical user interfaces, or GUIs for desktop apps. From there, we'll level up to web applications that can reach literally anyone on the planet. Just look at the progression here. As the technology gets more advanced, your reach as a developer gets bigger and bigger.
All right, quest number 1, breaking free from that boring old command line. It's time to build applications that don't just work, but are actually intuitive and, look good for anyone who uses them. This is the fun part. This is where your code finally gets a face. We're talking windows, buttons, text fields, all the stuff that makes an app feel like, well, a real app. This isn't just about making things pretty, it's your first major step toward creating truly professional, user-friendly software. Now to build that UI, Java gives you two main toolkits, AWT and Swing. The real difference here is the architecture. Think of AWT as heavyweight because it uses the operating system's own native components. What that means is your app might look a little different on a Mac than it does on a Windows PC. Swing, on the other hand, is lightweight. Java draws all the components itself, which gives you way more control and, most importantly, a consistent look and feel on any platform. And believe me, that consistency is a huge deal, and it's exactly why Swing became the go-to for modern Java desktop apps.
Okay, so we've built a beautiful interface. Awesome. But let's be real. A pretty face isn't much use without a brain, right? Our application needs to be smart. It needs to handle information and handle it well. That's our next big challenge.
And here's the million-dollar question, isn't it? A user fills out a form in your awesome new app. They click submit, everything looks great, but then you close the application and poof, it's all gone. Vanished. Why? Because it was just living in memory. It was never saved anywhere permanent. We need to fix that. So, the first part of the solution is managing the data while the application is running. For this, we have the Java Collections framework. You should seriously think of it as your personal, internal data library. It's a whole set of powerful tools, like super smart containers, to store and organize your data right inside your program.
Let's look at a classic choice every developer faces: array list versus linked list. This really highlights a fundamental trade-off. An array list is kind of like a row of numbered mailboxes. If you know the number, you can go straight to it. That's what we call fast random access. A linked list, though, is more like a conga line. It's super easy to pop someone in or out of the middle, but if you want to find the 50th person, you have to start at the front and count all the way up. Knowing which structure fits your specific task, that's the mark of a great developer.
So collections are fantastic for managing data in the moment. But to solve our original problem, that whole data disappearing act, we need to connect our application to an external permanent storage system. And for that, we need a database.
And how do we build that connection? With JDBC. It's basically the universal translator for your app. It doesn't matter if you're using MySQL or Oracle or some other database, JDBC provides a single, standard, consistent way for your Java code to talk to it. It really is the essential bridge between your code and your data.
And using this bridge is the super reliable 4-step process. First, you load the specific driver for your database. Then, you establish the connection. Third, you create a statement to hold your SQL command. And finally, you execute that query to read or write your data. Load, connect, create, execute. It's a pattern you're going to use over and over and over again.
We've built a visual application. We've connected it to a database so it has a memory. Now it is time for the final and, frankly, most exciting leap: taking our application online and making it accessible to the entire world.
This is where we totally shift gears. We're moving away from an app that one person uses on one computer to a system where many users or clients can all interact with a central server through their web browsers. This is the foundation of the modern internet. The absolute workhorse on the server side is the servlet. So when a user clicks a button on a website, a request gets fired off to your server. It's the servlet's job to catch that request, process it, maybe by talking to the database, and then generate a dynamic response, like a personalized welcome page or a list of search results to send back.
To really get servlets, you have to understand their life cycle. The init method is called only once, right at the beginning, to set things up. The destroy method is also called only once at the very end to clean everything up. But the service method? That's the heart of it all. It gets called again and again and again for every single request from every single user.
Inside that service method, you'll mainly deal with two types of requests, GET and POST. A GET request is like asking for information. Think of a Google search. The data is right there in the URL. A POST request, though, is for sending information to be saved or processed, like when you submit a login form. The data is hidden securely in the request body. So the crucial takeaway is this: GET is for retrieving, POST is for submitting.
Now, as powerful as servlets are for logic, they do have a weakness. If you try generating all your user interface, all that HTML code, from inside your Java code, oh man, it becomes a tangled nightmare. Fast. There has to be a more elegant solution for the presentation part, right?
And there is. The solution is JSP, or Java Server Pages. JSP completely flips the script. Instead of embedding messy HTML inside your Java code, JSP lets you embed small, clean snippets of Java inside your HTML. This creates this incredibly powerful separation. You use servlets as the controller to handle the business logic, and you use JSPs as the view to handle the presentation. It's that combination that makes for clean, maintainable, professional web applications.
And with that, our journey is complete. We've gone from a simple blinking cursor to a full-fledged web application. And you haven't just learned individual technologies, you've assembled a complete professional developer's toolkit.
Let's just recap what you can do now. You can build visual desktop apps with Swing. You can connect them to a database so their data is permanent. You can build a backend logic for a web application with servlets. And you can design the dynamic front end with JSP. You now hold the core skills of a full-stack Java developer.
So we end where we began, but with a whole new perspective. The question is no longer, now what? It's a much more exciting one. You have the full stack of tools to build robust, commercial-grade applications. So, what are you gonna build?